Hello again. So this is video number 4, part 2 for the subtopic the heart in the main topic transport in mammals. So let us continue. The next point we are dealing is the cardiac cycle. So here are the points you have to remember. So refers to the events of one complete heartbeat. Cardiac cycle is nothing but one complete heartbeat we are looking for. Okay. So both atria and ventricles contract, then relax. That is all the systematic procedure that is completing in about 0.8 seconds. Okay. If beating approximately 75 times per minute. So the key terms you should know here: diastole, systole, and the lub dub you already know, the sound created by the closing of the heart valves. So diastole means relaxation and the systole means contraction. So now just move on to the topic. So as we are learning about the heart valves allow blood flow in one direction only. They are opened and closed by differences in the blood pressure. According to the blood pressure, these valves are opening and closing by themselves. So here the cardiac cycle is the sequence of events of a heartbeat by which blood is pumped all over the body. As we know that heart beat at the rate of about 75 times per minute. So each cardiac cycle is about 0.8 seconds long. So this period of heartbeat is divided into two stages. Those are known as systole and diastole. In the systole stage, heart muscles contracts, and during the diastole stage, heart muscle relaxes. When the muscular walls of the chambers of the heart contract, the volume of the chambers decreases. So this increases the pressure on the blood contained there. This forces the blood to a region where the pressure is lower. So that means valves prevent blood flowing backward to the region of low pressure. So finally, the blood always flows on through the heart. So by this we will be understanding the valves will be opening when the pressure on the input side, that means caused by muscle contraction, and they are closed when the pressure on the output side exceeds that on the input side. That means this is caused by the relaxation of muscle on the input side. So by looking the picture, you will be understanding how the blood is pumping. Okay, so in the first notes you can see atrial systole, ventricular systole, and then diastole for atrial and ventricular. So when the pressure in the atria rises, that means the atrial walls are contracting. Okay, when the pressure is raised in the atria, in both the atria, that means that time atrial valves are contracting. So when these are contracting, vena cava and pulmonary veins are closed. By that, atrioventricular valves, here you can see the arrow is coming into the ventricles. That means the atrioventricular valves, that means AV valves we can say, those valves pushed open and the blood flows into the ventricles. Then ventricular valves relaxes. Okay, when the blood is coming into the ventricles, by the AV valves, that time the both left and right ventricles are in the relaxed position. That means the pressure is in low condition in the ventricles. So the semilunar valves are closed because the high pressure in the aorta and pulmonary arteries. This is because of due to the elastic and muscle fibers in their walls. Then the ventricular valves contract strongly because the pressure is raised in the ventricles. As the pressure present in the ventricles is raised, automatically the ventricular valves contract strongly. By this, AV valves are closed. Okay, here AV valves both are closed and the semi-lunar valves are opened. Then atrial valves relax. Now the atrial valves will be relaxes because the pressure falls in a atria. In both the atria, the pressure will be falls down. Then the vena cava and pulmonary veins will be opened. Then finally the blood flows into the atria. Okay. From there, the blood flows into the atria. The muscles of the atrial and ventricular valves are relaxed because the pressure in both atria and ventricles is low now. So the semilunar valves are closed. There is passive flow of blood from the veins into the atria and ventricles. So like this, one after each, it will be going on in a circular motion. Okay. So by this you can listen the sound that is making by the movement of the valves, that is lub dub. So here in the picture you can see clearly. Okay. So in both sides of the heart is the function is in same way. Okay. So here you can see the phases of the cardiac cycle, the same what I have explained up to now. Just for understanding, you can have a look here. So here you can see atrial systole begins. So atrial contraction forces blood into the ventricles. Here in the picture you can see it is clearly showing that the blood is coming into the ventricles from the atria. Okay, and then in this ventricular systole, this is the first phase, ventricular contraction pushes AV valves closed. Okay, so when it is pushing up, the AV valves will be closed. Then the semilunar valves open and blood is ejected. These are the semilunar valves will be opened when the AV valves closed. These two semi valves will be opened and the blood is ejected up. After that, the semilunar valves closed. Here they are closed and the blood flows into aorta. Okay. After that, ventricular diastole. This is the late one. The chambers relax and blood fills ventricles passively. Okay. So here you can understand that when the blood coming from the atria to the ventricles, because of the pressure, when the blood pushes up, that time the ventricular contraction pushes up, AV valves will be closed, then semi-lunar valves will be opened. By that, blood will be ejected out. After that, through the semi-lunar valve, when the semi-lunar valves are closed, the blood flows into the atria. Then, when the chambers will be relaxing position, blood fills the ventricles passively. Is that clear? So by this we can understand that the high pressure this generates lamps shut the AV valve and opens the semilunar valves, forcing blood into the aorta as I told you before. This is the pulse detectable in arteries all over the body. That is why when we hold our pulse we can listen the pulse because of this relaxation and contraction by the valves present in the heart. Then let us see how the pressure changes in aorta, left ventricle and left atrium. This is the graph you can see here for the pressure in mm of Hg, and this is in time. X-axis for time, y-axis will be the pressure. So here you can see the AV valves are closed, and then aortic pressure you can see here in the red line, and the green line is for semilunar valves coming like this. Okay, when the ventricular pressure, and here atrial pressure, and here AV valves open, and then semilunar valves will be closed here. So by the time of the in the seconds you can see this is the graph drawn by the ECG machine. ECG machine is nothing but electrocardiography. Electrocardiography. Okay. So here in the first stage, from here to here is the first stage you can see for the atria. This is in active passage. Then the ventricles will be in relaxation position. Okay. So when the atria are in active position, the bicuspid valve closes. That is nothing but AV valves will be closed when the atria is in active. So after that, when the atria relaxes, the ventricular valves will be in active position. That time the semilunar valves will be open. Here you can see. When the ventricular valves will be active position, that time semilunar valves will be open. Then in the third stage, that time the semilunar valves closes, and then the bicuspid valves will be open. Okay, this all because of the pressure in the ventricles pushing the blood upward direction into the aorta. Okay, so like that, when this graph is coming like that means this is the P wave we say. In the next picture I will explain you about this ECG graph. Okay, so when the pressure of the blood is having by the valves, the movement of the valves is giving the sound like this. The heart sounds. For the first one you will listen lub, and the second one you will listen dub. So like that, when you see the heartbeat, when you're listening the heartbeat, the sound will be lub dub, like that. So now move on to the electrocardiography. So electrocardiography is the equipment to find the impulses that originate in the sinoatrial node, that is nothing but pacemaker of the heart during the cardiac cycle produces a electrical current that also conducted through the fluid of the body. Okay. So here you can see the P wave is for depolarization of atrial contractions, and T wave is for repolarization, ventricular repolarization of the relaxation phase. And here you can see QRS for ventricular depolarization. So here you can see these all are the electrocardiograms for different heartbeats. For normal heartbeat you can see like this, and go through for these all three also. By that you will understand clearly. Okay, so that's all for today. See you in the next video. Have a good day. Stay at home. Stay safe. Thank you.